Hi, this is Sung, your online maths mentor, and we're going through the topic of circle geometry, right? And in circle geometry, there's a whole bunch of theorems that we need to be familiar with, which actually make up our toolbox to help us to do a whole set of deductive geometry proofs. Okay, now one of the some of the theorems that we've kind of gone through include theorem 5, which says that angles subtended at the circumference by the same or equal chords in the same segment are equal, right? So we did that last episode. In the episode before, we did one that said, which looked something like this. An angle subtended by an arc or a chord at the center of the circle is double the angle subtended by the arc or a chord at the circumference, right? Now this is the one I want to focus on, right? Because essentially what it is saying is this, and I want you to focus on the parts in red, right? Not on the parts in black just yet, but the parts in red. Because basically what this green bit says is this: when you've got an arc or a chord, let's say the chord here, A dash B dash, subtended, the chord A dash B dash, or the arc A dash B dash, then you will see that the angle subtended at the center to the chord, to the ends of the chord, is going to be double, right, the angle subtended at the circumference, right? Say at point C, right? So in other words, this point here is alpha, this point here is 2 alpha. You've got, where is it? You've got 2 alpha. So in other words, angle A dash OB, which is this angle here, is going to be 2 alpha, which is going to be twice angle A dash CB dash, right? Which is that angle there, okay? So even though I got tongue-tied saying it, you can visually see what I'm trying to say. This angle here is going to be twice that angle here. Now this is what I want you to visualize. I want you to visualize what will happen if we took these 2 points and slid them up into position A and B, such that OB would be the diameter of a circle. Do you see what I've said? Do you see what I've done? So AB would no longer be a chord. A dash B dash would move up into positions A and B, so that AB would be a straight line, but a straight angle as well. AOB would be a straight angle. Do you see what we've done? So in other words, what would 2 alpha be equal to for angle AOB? It would be 180 degrees, right? It would be a straight angle. So in other words, if this angle is 180 degrees, what does that say about angle ACB? It's going to be half the straight angle. ACB will be a right angle. Do you see that? Because this angle, the right angle, would be half the straight angle, AOB. Got it? That essentially is theorem 6, which says the angle in a semicircle is 90 degrees. And that would apply for any angle in any position along the circumference of the semicircle. Yeah? Because of this theorem up here, which says the angle subtended at the circumference by the same or equal chords. In this case, it's a diameter. The chord's a special type of chord. It's a diameter in the same segment are equal, and the segment will no longer be a segment anymore. It'll be a semicircle. Does that make sense? So essentially, the proof goes something like this. So angle AOB equals to 180 degrees. Angle AOB is also equal to 2 times angle ACB, okay, which is again theorem 4, and this one here is a straight angle, which will essentially mean that angle ACB equals to 90 degrees. Okay, good. And that is basically the angle in a semicircle theorem. Thank you very much for watching.